In modern aerospace manufacturing, precision begins long before paint ever reaches the aircraft. Every surface is digitally measured. Before the first layer is applied, Robotics confirms the airframe meets strict manufacturing tolerances, helping ensure consistent coating performance across composite structures.
Modern aerospace coating systems rely on synchronized robotic motion rather than manual application, help maintain consistently before the first coating layer is deposited.
Before every automated coating cycle, robotic applicators verify nozzle alignment, spray distance, and environment application across the aircraft's composite surfaces. With calibration complete, the automated coating cycle begins. Computer-controlled robotic motion helps maintain a consistent spray distance. Automation brings repeatability to complex manufacturing tasks. By following precisely programmed paths and continuously monitoring position, automation doesn't end with application. Throughout the process, integrated inspection systems continuously verify robotic positioning and manufacturing consistency is one of automation's greatest strengths. By repeating programmed movements and continuously monitors can produce highly repeatable results across complex airframe surfaces. In advanced manufacturing, application and inspection often work together as part of a continuous production workflow. Robotic systems can apply material. As production progresses, every robotic movement remains synchronized with inspection and environmental monitoring systems. Large-scale aerospace manufacturing depends on coordination as much as precision. Multiple robotic systems operate together within a carefully synchronized workflow. Complex aircraft require complex manufacturing. By combining coordinated robotic motion, continuous optical verification, automation extends beyond individual machines. Modern aerospace production combines robotic application designed to deliver frame structures. As production nears completion, automation continues to prioritize repeatability, ensuring that each manufacturing step aligns with the process requirements. After automated application comes automated verification. Non-contact optical inspection systems compare the manufactured geometry with digital engineering references. Digital metrology allows manufacturers to inspect complex aircraft surfaces without physical contact. By combining structured light scanning, laser measurement, quality assurance extends beyond a single inspection. Modern aerospace facilities combine automated measurement, environmental monitoring to verify each stage before an aircraft progresses. With automated coating and inspection complete, the production cell transitions to standby, while manufacturing records and environmental conditions are confirmed. Once inspection is complete, automated transport systems move the aircraft between production stations with carefully controlled precision. Precise positioning is essential before additional manufacturing operations can begin. Automated transport, laser alignment, and calibrated docking systems. Before production continues, automated calibration systems establish a precise reference position for the aircraft. Automated geometric verification confirms that continuously measuring position without physical contact. Aerospace manufacturers improve consistency. Automation doesn't end when the aircraft is finished. Every robotic work cell resets itself. Maintain consistent quality across every aircraft that follows. With coating, inspection, and geometric certification complete, the aircraft leaves this production department. Automated logistics systems coordinate each transfer. Large aerospace programs rely on synchronized automation far beyond a single workstation. As the aircraft reaches final integration, automated positioning systems establish an exact reference before manufacturing begins.